Bismillahirrahmanirrahim. Hello everyone, I hope you are doing well. I welcome you all in class of Elementary Number Theory by David M. Burton. Our discussion is continue on problem 2.3. Lastly, we covered up to question number uh, 20. In today's lecture, we will start from question number 21. And inshallah, in this lecture, we will cover the complete exercise. So let us start from question number 21. The question number 21 A part is stated as prove that if D is a divisor of n, that is D divides n, then show that 2 raised to power D minus 1 divides, this vertical line is read as divide. 2 raised to power D minus 1 divides 2 raised to power n minus 1. It is given that D divides n, D is divisor and n is dividend. So by definition of divisibility, when D divides n, then there exists an integer k such that we can write the dividend d n is equal to d times k. In other words, n is a multiple of d. Substituting this value of n in the expression 2 raised to power n minus 1. So we have, when we substitute n is equal to dk, we have 2 raised to power n minus 1 is equal to 2 raised to power dk minus 1. By using the law of exponent, this number can be written as 2 raised to power d whole power k minus 1. We suppose this number 2 raised to power d is equal to x. Now again consider the original expression 2 raised to power d minus 1 divides 2 raised to power n minus 1. This can be written as we set 2 raised to power d is equal to x, so this becomes x minus 1, and 2 raised to power n is equal to 2 raised to power n becomes, this is equal to, as 2 raised to power d is equal to x, so this becomes x raised to power k minus 1. So the numerator becomes x raised to power k minus 1. By using the identity, the algebraic formula x raised to power k minus 1 is equal to x minus 1 into x raised to power k minus 1 plus x raised to power k minus 2 up to so on x plus 1. Clearly this formula have the factor x minus 1. This shows that x raised to power k minus 1, this is divisible by x minus 1 because this expression involving the factor x minus 1, which shows that x raised to power k minus 1 is clearly divisible by x minus 1. So star hold. Star, what is star? This is my star. I have to show that 2 raised to power d minus 1 divides 2 raised to power n minus 1. So this hold. Its B part is, we have to verify that 2 raised to power 35 minus 1 is divisible by 31 and 127 by using A part. Here n is 35. If you compare 2 raised to power 35 minus 1 by the number 2 raised to power n minus 1, we have n is equal to 35. As 5 divides 35, so we set here d is equal to 5. In the question, we have proved that 2 raised to power d minus 1 divides 2 raised to power n minus 1. So when you compare this number 2 raised to power 35 minus 1, we get n is equal to 35. Now as there are as 5 divides 35, so according to this question, d was the number that divides n. So here our d is 5. So by using A part, 2 raised to power 5 minus 1, that is 2 raised to power d minus 1. This number divides 2 raised to power 35 minus 1, but 2 raised to power 5 minus 1 is equal to 31. This shows that 31 divides 2 raised to power 35 minus 1, which is required. Again, we have to show that 127 also divides this number. As 35 is also divisible by 7, so now our d is 7. So according to A part, this number 2 raised to power 35 minus 1 is divisible by 2 raised to power 7 minus 1. But 2 raised to power 7 is 128, and 128 minus 1, this is 127. This shows that 127 divides 2 raised to power 35 minus 1. Next question is very interesting. Let Tn denotes the nth triangular number. For what value of n does Tn divides the sum T1 plus T2 up to son Tn? Uh, in problem 2.1, we discussed the concept of triangular number in very detail. So if you have not seen that lecture, please see that lecture firstly. So what is formula of nth triangular number? As we know that nth triangular number is given by Tn is equal to n plus 1 combination 2, that can be written as n plus 1 into n over 2 by using the rule of combination NCR, which is equal to n factorial over r factorial into n minus r factorial. So when you use this formula over this, we will get n plus 1 into n over 2 by just this is equal to n plus 1 factorial over 2 factorial into n plus 1 minus 2 factorial. Now when you break both of the factorials, we will get this expression. And further, we also know that the sum of these n triangular number is simply given by n into n plus 1 into n plus 2 over 6. These formulas are given in problem 2.1. Now we have to show that we have to find such value of n for which this complete sum is divisible by Tn. Tn means nth triangular number. So we consider the fraction, numerator is sum and the denominator is triangular number. Now as the sum of these n triangular number is simply given equal to n into n plus 1 over 2, n plus 2 over 6. So when you divide this number by Tn, my Tn is equal to n plus 1 into n over 2. This becomes 2 over n into n plus 1 after division. So after cancellation, we have remaining n plus 2 over 3. Now we have to find such n for which the numerator is divisible by denominator, and this fraction becomes n plus 2 over 3. Now we have to find such values of n for which the numerator, that is n plus 2, is divisible by 3. So this is possible that n plus 2 over 3 will be an integer. Clearly when n plus when 3 divides n plus 2, the answer will be an integer. So that's why I am writing here n plus 2 over 3 will be an integer if n plus 2 is a multiple of 3. For example, when numerator is 3, then 3 divides 3 and answer is 1. When the numerator is 6, when again your answer is 2. So in all cases, when your numerator is a multiple of 3, then the numerator is divisible by 3. So in short words, n plus 2 should be multiple of 3. So in other words, we can say that n plus 2 should be equal to 3k, and our n is of the form n is equal to 3k minus 2. Now if you put k is equal to 1, our first n is equal to 1. Clearly when you put n is equal to 1 here, your answer is 3. 3 is divisible by 3, it's okay. When you put k is equal to 2 here, our n becomes 4. This becomes 4 plus 2, that is 6. 6 by 3, this is divisible by 3, yes. When k is equal to 3 here, your n is 7. You can guess directly which n will work here. For example, when you put n is equal to 1, your answer is 3. When you put n is equal to 4, your answer is 4. When you put n is equal to 2, your answer is when you put n is equal to 4, your answer is 6. Numerator is 6, that is divisible by 3. When you put n is equal to 7, your answer is 9. So you can directly guess which n will work here. Otherwise, after substituting the values of k, you can get infinite n from here. So the required values of n are given by this arithmetic progression 1, 4, 7, 10. Further, just for your knowledge, why am I not taking here the negative values of k? Here we cannot take k less than 1 because in that case our n becomes negative. But we need n should be positive, because because it is given that in when you define a triangular number, then n must be greater than equal to 1. So in short words, your n should be 1, 4, 7, 10. These are the values of n for which the sum of n triangular number will be divisible by nth triangular number. Lastly, question number 23 says if A divides the product of BC, product of B and C, show that A divides GCD of AB and GCD of AC. It is given that A divides B. So by definition of divisibility, there exists an integer k such that we can write BC, that is the dividend, is equal to A times k. Say this is my equation number 1. We suppose that the GCD of A and B is equal to D1 and GCD of A and C is equal to D2. It means we will show that A divides, now as we have set this number is equal to D1 and the second GCD is equal to D2. So we will show that A divides D1 into D2. This is our target. As GCD is the least positive integer that can be expressed as a linear combination of the corresponding integers. This is the Bayes-out lemma that we discussed in our previous lecture. That GCD is the least positive integer that can be expressed as the least positive linear combination of corresponding integers. So when you consider this GCD as the GCD of AB is equal to D1, so according to this result, there exist integers x0 and y0 such that we can express D1 as the linear combination of A and B. As you know, this form ax0 plus by0 form, sum of product, this form is called linear combination. So D can be written as in this form, D1 can be written as in this form. Similarly, when you consider second GCD of A and C, this is equal to D2. We will find other integers x1 and y1 such that we can express D2 as a linear combination of x1 and linear combination of A and C. That is A into x1 plus C into y1. This is equation number 3. Now I have to show that A divides D1 into D2. That is, this is a product of D1 and D2. That's why we are multiplying question number 2 and 3. So multiply question number 2 and 3 gives, we have D1 into D2. This is the value of D1 and this is the value of D2. So when you multiply, we get this sum. Now using question number 1, which says this number BC is equal to A times K. This is my question number 1. So substituting the value of BC here. So when you substitute here BC is equal to A times K1, the whole expression contain A. So taking A as a common factor, we get A into x1, x0 into x1, C into x0 into y1, B into x1 into y0, and here we have the number AK, y0, y1 after substituting the value of BC, which is equal to AK. So the remaining is K into y0 into y1. As x0, x1, x0, y0, x1, y1, a, b, c, k, these are all integers. And you know the sum of product of integer is always an integer. This shows that if you said this whole expression is equal to some integer m, so this becomes A times m. This shows that D1 is equal to D2 is equal to A times m. And this fulfills the definition of divisibility. According to this definition, A divides D1 into D2 for some integer m. Or we can write as A divides GCD of AB and GCD of AC. And this completes the problem 2.3. Inshallah, in the next lecture, we will discuss Euclidean algorithm. That is very interesting. And actually, this topic is used to find the GCD of two or more than two integers without making their prime factorizations. So see you in the next lecture. If you find this lecture is helpful, kindly like, share and subscribe my channel. Take care. Allah Hafiz.